Okay, so we left off on this slide, slide 33, and we're talking about cyclic compounds now, and we're using the IUPAC naming system, which looks at the longest continuous chain, and today we're going to talk about things that attach to that longest continuous chain. So cyclic compounds are where like the tail is attached to its head, and we name them by putting cyclo in front of the parent chain. We learned yesterday that the parent chain is based on the longest continuous chain. Table P tells us how many carbons that is by meth, eth, prop, but. And then table Q tells us if there's single bonds between the carbons, if we have an ane, an ene, or an ine. So continuing on here, cyclopropane means that I have the tail attached to its head and I have 1, 2, 3 carbons. The longest continuous chain is a prop, and it's an ane because there's single bonds, and we put cyclo in front. Sometimes I'll draw the structures like this to show the carbon backbone and eliminate the H's. So that's cyclopropane. Here is cyclobutane. We have 1, 2, 3, 4. That's a but in terms of table P. Ane because there's single bonds, and cyclo because they're cyclic. Okay? The tail is attached to its head, so to speak. In cyclopentane, again, we're getting that nice structure of a pentagon because we have 1, 2, 3, 4, 5 carbons. It's a pent. Ane because there's single bonds, and cyclo because they're cyclic. They're attached to their heads, so to speak. All right, so knowing that, what's the name of this compound? Well, you're just looking at the bare backbone of the carbon backbone, count the corners. 1, 2, 3, 4, 5, 6. If you look at table P, you'll see that 6 carbons is a hex. And because you don't see a second bond here, you're going to assume one bond. That's an ane from table Q. And so we call this cyclo for the cyclic structure it makes, hex for 6 carbons, and ane for single bonds. You're going to see that the naming system describes the structure. Structure is king here, always. And you should be able to draw the structure based on the name, or name it based on the structure. That's why the IUPAC system was such an important system. It's based on structure alone. Once we know the structure, the name will come from that structure, and vice versa. So as we continue on, now we're going to add substituent groups to the parent chain. When a substituent group is attached to a parent chain, you must name the group that's attached to it. Now the parent chain is the longest continuous chain of carbons. So let's add one here. Let's bring this up. So if you notice, the longest continuous chain of carbons here is 1, 2, 3, 4. That's 4 carbons. And we call that a but. All right, 4 carbons has that prefix of but. And because there's single bonds between the carbons, it's a butane. But we're going to attach something to this butane molecule. So we're going to put a Grodsky there. Yeah, there he is in all his glory. So I've got a Grodsky on this butane chain. So we're going to call it a Grodsky butane, but not good enough. Where that Grodsky is important. So we have to count carbons now. Now we can put this Grodsky and call it on the second carbon, or we can say the Grodsky is on the third carbon. Here's how I'd go about doing that. This is the first, second, third, and fourth carbon, or I can make this the first, second, or 3. So I've got 2 choices. Put them on the second carbon, or put them on the third carbon. Well, by convention, by the naming system, we put the attaching groups, the substituent, on the second carbon. So this is a 2 Grodsky butane. The 2 is telling us where the Grodsky is located, and the butane is the parent chain, or the longest continuous chain of hydrocarbons that does that. All right? So continuing on, we have another longest continuous chain hydrocarbon here, and to find this longest continuous chain, or parent name, we count the carbons. 1, 2, 3, 4, 5, 6. So that would be a hex if you've got table P out. And we're going to attach something to this carbon. So if I attach something, let's bring in another Grodsky. All right, there he is. Okay, just hanging out on a Saturday. Why not? You wear hats on Saturdays. But where is the Grodsky attached to? I'm attached to the third carbon or the fourth carbon? Right, I'm attached to the third carbon. We always put the substituent on the lowest carbon number. So what's the name of this? If Grodsky does exist and I was attached to a hexane, you would say that on the third carbon, there is a Grotsky, and it's attached to a hexane. That's how we do this. All right, so 3-hexane, 3-Grotsky hexane is how we name it. And the name describes the structure. And it's important because if the Grotsky was on the second carbon or the first carbon, the structure would be different and the properties would be different. Remember, the names are very important because structure is king. It's based on the name. So let's continue. All right. So now we're going to take away the Grotskys and now talk about real attaching groups. And I have a meth and an ethyl group. If you look at your table P, you'll see that a meth is a 1-carbon group and an ethyl is a 2-carbon group. All right, and you notice there's a dash here because this carbon is attached to a chain. So this carbon, knowing it has to bond to 4 different things, would have 3 carbons. This ethyl group is attached to a carbon chain, and then it's got 2 H's, and then it attaches to another carbon, so it only's got room for 2 H's. This ending carbon's got room for 3 H's because of it being terminal. Okay, so in any case, we're going to see where the methyl and ethyl groups come out of. You'll notice, hard to see. There's no Grotsky with a hat on or being crazy attached to a chain. So the first step when we look at a compound is find the longest continuous chain. All right? So if I was to count 1 carbon, 2, 3, 4, 5, and 6, we can see on the 5th carbon, this is not part of that longest continuous chain. So on the 5th carbon, I've got a methyl group. Or I could count this way, 1, 2, 3, 4, 5, 6, and you can see on the 2nd carbon, I'd have that methyl group. So it's the 2nd carbon. So here we go. For instance, we could count the numbers this way, as I just said, and put the 5 here and see that this is not part of the longest continuous chain, and that methyl group, 1-carbon group's on the 5th carbon. Or, is this correct? And of course, Grotsky says no. He says rock off. We should count this way, like I just talked about, that the 2nd carbon would have the methyl group, so that the attaching group had the lowest numbers possible. Now, could I count this as my first carbon, and this as my 2nd? Absolutely. If I make this 1, 2, 3, 4, 5, 6, this would be my what? Methyl group that I'm talking about. So whether this is my methyl group, if I make this the 1 carbon and the 2nd carbon, or if I make this the 1 and this is the methyl group, it doesn't matter. It doesn't matter because these things can rotate on their single bonds. So the name of this, well, on the 2nd carbon, I've got a methyl group. And the longest continuous chain is a hex. Do I have single bonds? And you may look at this, well, how do I know written this way? Well, a terminal carbon bonds to 3 other carbons because carbon must make 4 bonds. So it's got 1 bond left to bond to this carbon. And this carbon bonds to another carbon. So if this carbon is bonding to these 2 carbons, this is a secondary carbon, okay? Then it only has room for 2 more H's if it makes 4 bonds. So this one's also a secondary carbon that's at the end, okay? So it can only bond to 2 other carbons. It only has room for 2 H's. So you can see that CH2 only has room for 2 H's if it's bonded to 2 other carbons. This carbon is bonded to 2 other carbons. Actually, it's bonded to 3 other carbons. We call it a tertiary carbon. Now this carbon only has room for 1 H. So you can see that this kind of tells you that this is single bonded. So the name of this is 2-methylhexane. The 2 on the 2nd carbon of my hexane, I've got a methyl group, a 1-carbon group. You can't call this 1, 2, 3, 4, 5, 6, 7 a heptane. Longest continuous chain, and then you see what's attached to it. All right? So moving forward, we've got this compound. And we can try numbering carbons as many ways as possible, and you should. Is it a 1, 2, 3, 4, 5, a pentane compound with a 2-carbon group called an ethyl? Or is it a 1, 2, 3, 4, 5, 6? What's the longest continuous chain? I don't care that I've drawn it bending downward. These things can spin and turn on themselves, so who cares if they bend downward or upward? So my friends in chemistry, I could count like this, 1, 2, 3, 4, 5, and at 6. And of course, this is my methyl group that pops up. Find your longest continuous chain. I don't care how many ways you have to count. 6 is my longest continuous chain. And then, who's not part of that longest continuous chain is your attaching group if they're carbon-based. So there's my methyl, it's on the 3. Okay, so the name, you can stop this if you'd like, stop me. Actually, I wasn't really stopped there. All right, the name, of course, is a 3-methyl hexane. On the 3rd carbon, I've got a methyl group, and it's attached to a hexane, single bonded. All right, moving forward. What's the name of the following compound? All right, well, you've got to do what? You've got to count the longest continuous chain. That's what we've got to do here. All right, because you just can't say, well, 1, 2, 3, 4, and that's a butane. No, 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 no. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No matter how I count, the longest continuous chain here is going to have 6. So again, it's a hex. And if you look at your carbons and hydrogens, okay, you'll see it's a hexane. And there pops out my methyl group. And of course the name is 2-methyl on the 2nd carbon, and then we have this hexane molecule, 2-methyl hexane. All right, good enough. But could this be the methyl group? If I made this 1, 2, sure, who cares? These things can spin. So this could be the methyl, or this could be the methyl if this was 1, but the bottom line, your longest continuous chain is 6. That's why it's a hex, and you're going to have a 1-carbon group. All right, moving forward. What's the name of this compound? Well, I have a cyclic compound. 1, 2, 3, 4, 5, 6. So it's hex. You don't see a double bond, so you assume ane. It's the head's attached to its tail, so to speak. So it's a cyclohexane, and you've got a 2-carbon group here. And we would call a 2-carbon group an ethyl group. So this is ethyl, cyclohexane. There's an ethyl group. Now we don't use numbers here because if it's attaching to 1 carbon, who's to know where the numbers are? If you start having a 2nd carbon, we'd start putting some number, maybe something called parameta. There's other things that come into this right here, but this is good enough for right now for this course. Okay, moving forward. Oops, what's that? Oh, sorry. Okay. Now, multi-substituents. When there are more than one of the same attaching group to a hydrocarbon, you must identify exactly where and how many exist. So, now we're going to have more than one attaching group. For instance, now we bring back our compound here. And you can see it's a 1, 2, 3, 4, 5, 6. Our longest continuous chain is a hexane. And on the hexane we have 2 what? Well, we have 2 things attaching. And we're going to make them the same, and we're going to bring back our 2 Grodzkis. So we've got a Grodzki on this carbon, a Grodzki on this carbon. They're attached to the same what? Longest continuous chain, which is a hexane. And we're going to name these guys. Now, the thing is, there's 2 Grodzkis. They're both Grodzkis. So we're going to put di in our name to say that there's 2 of them. But just like I said before, where they attach has to be on the lowest number possible. So I can say this is on the 3rd and the 6th carbon, or I can say the 1st and the 4th. So we would say 1, 4, so that our attaching groups are always on the lowest number possible. We're going to use the word di to mean there's 2 of the same. If there was 3 of the same, we'd use tri. If there was 4 of the same, we use tetra. Okay, so we put di to mean there's 2 of the same. And then we say di-Grodzki because this is the name of the same group. They're both Grodzkis. I know they look a little different. But 1,4-di-Grodzki, and that would be hexane. So 1,4-di-Grodzki hexane. What does that mean? It means on the 1st and the 4th carbon of my hex 6-carbon molecule that's single bonded, I've got Grodzkis. Okay? So let's try some. So what's the name of this? Okay, well, longest continuous chain is first. Meth-eth-pro-bute, or 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. The longest continuous chain is 4. So 4 carbons, the bonded single is a butane. So let's just make it simple and make this our longest continuous chain right here. Now, who's attached? Well, we've got a 1-carbon group here and a 1-carbon group here. So I've got a 1-carbon group called a methyl on this carbon, a 1-carbon group on this carbon. So what do you think you have there? Well, you know you have a butane, but you got them on the second and the third no matter how you count. So the name of this is going to be 2,3-dimethylbutane. Why? On the second and third, no matter how you count, because these are the inside carbons, 1, 2, 3, 1, 2, 3. If this is my longest continuous chain, I've got a methyl group on my second and a methyl group on my third. And I put di in front. And you notice I have a number for each of them. You just can't say dimethylbutane. Where are they? Remember, the naming system is based upon the structure. Okay, let's try another one. Very simple. Longest continuous chain. Find that. Find that parent name. And you can see 1, 2, 3, no. 1, 2, 3, 4. 4. So it's a but again. Single bonds between the carbon. This is butane. Now on my butane, what's attached? Oh, another methyl group here, another methyl group here. So I've got a dimethylbutane again. But what's the numbers? 2 dimethylbutane? That's not enough. You got to give me a number for each attaching group. So we would say 2, 2. Now why not 3, 3? 1, 2, 3. Why not 3, 3 dimethyl? That's right. You have to put the numbers on the lowest numbers possible. Okay? It's part of the IUPAC naming system. So we would say 2, 2 dimethylbutane. What does that mean? On a butane molecule, you have 2 of the same, each on the same carbon. Every attaching group has a number. And if you can see the magic in this naming system, if I just give you this name, you should be able to draw this structure, right? I've got a butane, I've got 2 methyls, and they're both on the same carbon. You should be able to figure that out. That's what's nice about this system. Moving forward, how about this one? This one's a little different, but we can do this. Count the number of carbons. Longest continuous chain, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. No matter how you want to count, the longest continuous chain is 6, so it's a hexane. And if you notice, I've got a 2-carbon group attached, which is called a ethyl, and a 1-carbon group called a methyl. And where are they attached? Are they attached to the 3rd and the 5th, or the 2nd and the 4th carbon? The 2nd and the 4th is the lowest number. So we have a methyl on the 2nd, and we have an ethyl